I'm Katie Lively.
I'm Shane Gallagher.
I'm Zaid, Srour, and we're going to be talking about nuclear waste disposal methods. Specifically, we'll be comparing the storage of the waste with waste recycling. So, why should we care about nuclear waste and how it is disposed of, besides the obvious radiation risks associated with it? As of 2010, the US generates 2,100 to 2,400 tons of spent nuclear fuel per year, and we need to find a method for dealing with that fuel. Since commercial nuclear power generation started about 50 years ago, 64,000 of spent nuclear fuel has accumulated. This fuel is currently just being stored temporarily on reactor sites until the government finds and approves of a solution to the nuclear waste issue. Currently, the US government has no concrete solution for what should be done with spent nuclear fuel. But before we can make a recommendation, we need some background information on storage and recycling of nuclear fuel.
First, we're going to discuss what is involved in a nuclear waste recycling process. Waste recycling process is defined as the chemical separation of uranium and plutonium from spent fuel. This process has existed since 1960 when it was used initially to recover plutonium to make weapons. Most common recycling methods include plutonium-uranium extraction, or PureX for short. This process starts with spent fuel being cut into small pieces, which are dissolved in nitric acid and then subjected to a solvent extraction process using tributyl phosphate, or TBP for short. Uranium and plutonium are separated here from fission products and actinides, which are kept in the acid. Uranium and plutonium are then separated from each other using extraction and are purified. Since the invention of this process, many countries now utilize this technology to make their nuclear power generation process more efficient. These countries include France, Japan, Russia, India, and the United Kingdom. Next, we will discuss the basics of spent fuel storage.
Spent nuclear fuel storage is defined as a selection of appropriate deep final repositories for high-level waste and spent nuclear fuel. Long-term waste disposal using storage requires looking at a long time period, from about 10,000 to up to 1,000,000 years. Planning this far in advance is impractical since it is impossible to predict all the circumstances that may occur in that time period. As a result, practical studies consider up to 100 years as effective planning. What is currently being done by the U.S. qualifies as nuclear waste storage. However, it is not meant as a permanent solution. Dry cask storage is how the waste is stored now on site. This process typically involves taking waste from a spent fuel pool and sealing it with an inert gas in a steel cylinder. This is then placed in a concrete cylinder which acts as a radiation shield. The permanent storage option for the U.S. is deep geological repositories. This involves locating a large, stable geological formation and then excavating a tunnel that is 500 to 1,000 meters below the surface where the spent fuel can be stored. The Nuclear Waste Policy Act obligates the Department of Energy to provide a permanent storage solution for the spent nuclear fuel from reactors. Amendments to this act specified that the repository site would be Yucca Mountain in Nevada, as you can see in the picture. However, since President Obama has been in office, his administration has announced its intention to look for other options for nuclear waste storage, which is why Yucca Mountain is not currently being used as a permanent waste disposal facility.
To help us determine the best option for nuclear waste disposal, comparing the positives and negatives of our top options is crucial. The benefits of recycling include that it reduces the total volume of high-level waste needing to be stored, which reduces the thermal load of the repositories. It also reduces the radiotoxic inventory and simplifies the long-term storage process. Finally, it extends the lifetime of nuclear fuel, ultimately requiring less uranium to be mined. The benefits associated with storing the spent fuel include that there is a scientific consensus that the best disposal option for highly toxic waste is underground. Also, the permanent disposal of the waste does not require future maintenance. And in terms of economics, it's cheaper to mine more fuel than to reprocess the spent fuel. Drawbacks with recycling are that it is not economically competitive, as just stated, and there is the threat of proliferation. Costs with storage of spent nuclear fuel include that there is the potential for leakage, especially since the time frame involved is so long, which is another downside. And sites require specific geologic requirements. Finally, the repositories are expensive to build because of the measures that need to be taken to ensure their safety and security.
Another consideration that needs to be taken into account when deciding on a waste treatment process to pursue is the politics associated with each method. This timeline outlines the major political events surrounding nuclear energy. Starting in 1977, the United States changed their policy regarding recycling of spent fuel, which resulted in the end of any civil reprocessing. This was done in an effort to prevent proliferation. Then, in 1982, the Nuclear Waste Policy Act was passed, which required the Department of Energy to provide a permanent waste storage site for the disposal of spent nuclear fuel. This act named 3 possible repository sites: Yucca Mountain, Nevada, Hanford, Washington, and Deaf Smith County, Texas. Then, in 1987, this act was amended to name the Yucca Mountain, Nevada site as the only repository site for nuclear waste disposal. In 1998, the Department of Energy missed its deadline for the removal of spent nuclear fuel from reactor sites. As a result, the DOE has been in breach of contract for almost 15 years now. Because of this, many companies have exceeded the capacity for their temporary storage and have thus had to add additional storage facilities. To pay for these facilities, companies have filed over 71 breach of contract lawsuits against the Department of Energy, and over $7 billion has been awarded from the Treasury's General Judgment Fund. Then, in 2002, Yucca Mountain was deemed a scientifically and technically sound facility. In 2009, Yucca Mountain was deemed unsuitable by President Obama's administration, as well as Department of Energy Secretary Chu. The President's administration defunded the Yucca Mountain project. In the year 2010, first, in January, Secretary Chu named a panel of experts to explore other disposal options for nuclear waste. Then, in March, Secretary Chu withdrew the Yucca Mountain license application, effectively discounting the only permanent nuclear waste disposal option for the United States. All of these political events have helped us come to a final recommendation on what nuclear waste disposal methods should be pursued.
Based on this information, we have come up with the following conclusions and recommendations. The United States should lift the ban on civil reprocessing in order to meet our energy needs and waste management problems. We have reached this conclusion on the basis of the following 3 points. First, recycling spent fuel reduces the total amount of waste stored and fuel used. This has obvious environmental benefits. Second, the threat of proliferation can be addressed. We can see that other countries have been using reprocessing techniques to improve their nuclear fuel cycles. The fact that they have been able to do so without significant incident suggests that there is a way to utilize this technology as a peaceful solution to energy demand. Also, some policies have been presented as possible solutions to prevent proliferation while still allowing recycling. Finally, as the number of countries with nuclear technology increases, it will become increasingly difficult to manage the spread of recycling. Therefore, banning it in the United States is an ineffective way of facing the problem. Third, the economical benefits outweigh the costs of storage. The United States has spent billions of dollars in order to find a suitable permanent storage solution with no success. Even though the economics of recycling need further analysis, when comparing the amount the government has spent on Yucca Mountain and now on new research, as well as what it will have to pay in companies currently storing spent fuel on site in breach of contract lawsuits, recycling could be an economically feasible option. All of these facts point towards recycling as the best option for disposal of nuclear waste. Thank you for listening to our presentation, and we hope that this has helped inform you on the different nuclear disposal options that are at our disposal.
I really did not intend to have that pun at the end.